and thanks so much for joining me for this question, which looked complicated, but ended up not being that hard. It was really just substituting into the equation that you were given. But it explores this idea of interference, and that double slit experiment really was a fundamental experiment in physics, and we can do a variation of that. Instead of having two slits, we can just separate the light beam by having a very thin wire in between it. And so that image in the exam isn't something that was faked or stolen off the internet. It's something that's pretty easy to create, and I created it for myself. So to find really fine wire that's sort of about the dimensions that you're looking for, all you need is the kind of wire that you can find in the laboratory. Just strip off some of the plastic, separate out one of those very thin strands there, sticky tape it to a frame, and you've got your piece of wire, which is going to interfere with the laser light that goes either side of it, demonstrating pretty clearly that light is a wave, not a particle, except it's wave-particle duality. The laser that I used is actually off my little laser tape measure that I use when I'm building. It's pretty amazing. So there's the smaller aperture there is where the laser light comes out, and the larger aperture has a lens, and that's where the light gets reflected. It actually works off time of flight. So a pulse of laser light travels, bounces off the object, comes back, and it measures the time delay. Now, bats do that with sound, traveling at 330 meters per second. This is traveling at 3 times 10 to the 8 meters per second. The speed of light is phenomenal, and the fact that they can measure down at that kind of distance with a time of flight, pretty amazing piece of technology. But you'll notice that the aperture there, that really confused me at the start. I had a very long distance of about 8 or 9 meters, and I was seeing an interference pattern that suggested that the wire was way, way thicker than I knew it was going to be. It was kind of way out of the ballpark figure. It took me a while to realize that that was actually the interference pattern caused by that, not by the wire. The interference pattern caused by the wire was so large it was out of my field of view, because that's why it's kind of 1 on D there. Okay, so at a more reasonable distance of a few meters, we can see that the pattern is there very clearly, and that finer pattern looks like a bit of a fingerprint you can see over the top of it. Interesting how that aperture creates yet another interference pattern. Interestingly, here's a different kind of laser pointer, the ones you get from those kind of presentation pointers, and its image on the screen is this very kind of noisy, scattered interference, and I'd love to know, it is some kind of interference pattern. I'd love to know more about why that's happening. They're both two solid-state red lasers, and yet some very different patterns from them. If anybody knows, reach out. I'd love to kind of know. Now in part B, you're asked to come up with a plausible other method, something that wasn't using interference. And I'm going to be honest, it was inspired by originally kind of getting confused about where this other interference pattern was coming from. And I knew that it was ballpark, just, ridiculously large for the wire that I was using. And this is what scientists do a lot of the time, is that we'll do another way of getting at the same answer as a bit of a sense check. Are we kind of in the right sort of ballpark? It also illustrates another principle in physics and in science experiments. It's always better to measure kind of a large number of repeats of things and then kind of divide it down if you want to find a very, very small measurement. You're less at the mercy of your degree of uncertainty of your measuring your instrument. So if you were using, say, a ruler, then plus or minus 0.5 millimeter is the best that you can do. But if you were happy to sit there and wind 1,000 turns of this wire onto some sort of cylinder, tightly packed, you'd actually get a reasonably accurate measurement for that. So my last little bit of advice on this is around exams and exam technique. Part B on this question, and sometimes it can get hard to kind of think outside the box when you're in the confines of a question about interference patterns or whatever, and think about a different method that you can use. So just be aware that examiners, and especially physics examiners, like writing questions that draw upon multiple parts of the syllabus. Also be aware that working scientifically makes up 60% of the physics course, and you should expect questions there that ask you to demonstrate your competence with those kind of broader set of working scientifically skills. All the best.